When we started it, the challenge was, how do you create a new communication tool that allows the discussion around molecular biology to spread in a broader space?
I have been always very interested in trying to convey the importance of biological molecules to the greater public. Young people have always enjoyed going to planetariums and looking at planets, and yet their own bodies are filled with amazing things going on. And if I could make a difference, or we could make a difference in being able to show inner space the same way as we show outer space, I think we can make a big contribution to our society.
We created the project in order to try to integrate all the different types of data, the molecular data, the cellular data, the healthy, the disease data, all together. And then our real goal is to be able to do this at the entire human scale.
When I first met Dr. Ray Stevens 5 years ago or so, the original discussion was trying to identify the complexity of a single cell. When I was asking him, what does that system look like? How complex is it? He said it was the equivalent of a large city. How do we allow people to enter a system that is that complex?
We increasingly have a public that is either ignorant of science or mistrusts science. Scientists, they've been trained to tell stories to each other, and the problem is that those stories then are very difficult to translate for a non-expert audience.
There is so much value in the science and research that I'm doing if I'm able to actually communicate it well so that other people can appreciate it.
One of the provocations from Ray Stevens was, scientists don't know how to tell stories. This is fundamentally an art science project, and from the very beginning we brought artists and scientists together within USC, within the different departments.
The objective was to build out the entire pancreatic beta cell out of one building module, to kind of break things down, break the science down into building blocks.
The pancreatic beta cell is so important for understanding type 1 and type 2 diabetes. If we really want better treatments, we're going to have a community that understands the pancreatic beta cell.
We're deriving all the coordinates for how the protein structures are rendered from the protein data bank, so it's all based on actual coordinate data done by the scientists.
The first time I went into the Oculus and experienced the activation of the GLP-1R receptor, it was incredibly exciting for me. I had been studying these kinds of proteins basically my entire scientific career, and it was the first time that I really got to experience what it was like to be inside the binding pocket. What I saw as huge potential was for my students to really get that boost of creativity earlier on in the process. And one of the things that was really interesting to me is that a lot of the undergraduate students seemed to kind of latch onto this better than some of the senior faculty did. They weren't pre-biased by how we should approach science. They weren't biased by how we should think about complex biological systems.
The visual language we're developing can become the core language of education of molecular biology.
Another area that I'm very interested in is medicine and the way in which you communicate with patients, and hopefully by looking at this, patients will understand better about diabetes.
What we really need to get across to them, if I'm looking inside my body, if we're going to do Fantastic Journey, and this is a vision inside of my body, and I have diabetes, how is this different from a person who doesn't have diabetes?
The goal of the project is to really engage people in learning about their diagnosis so they can actually understand it and also feel empowered by that knowledge.
World in a Cell makes the data intuitively accessible to me, to other scientists, and to the public at large.
Its entire reason for being is to be able to translate complex systems from one space into comprehensible systems in another. If they can be controlled algorithmically, if they can input data and output translation, then we're really building something powerful.